Imagine discussing these statements with students. Switching to a carbon-neutral economy will stop climate change. All newly constructed buildings should be designed and certified as green buildings. A classroom hydroponic system can grow food that provides balanced nutrition for people. Reusable shopping bags sustainably reduce consumers' ecological footprint. These statements contain arguments that attempt to persuade the audience and perhaps influence our behavior. As educators, we can teach students to critically interpret, analyze, and evaluate such statements. We can also teach students to critically consider their own assumptions and points of reference when they consider scientific ideas. This can help us to avoid a situation where our actions and those of our students are guided by unverified facts, half-truths, and dominant viewpoints. Critical thinking involves assessing the credibility of sources of information, being able to reach decisions based on credible information, and being open to changing one's decision as new information emerges. For example, when presented with the statements I made at the beginning of this lecture, critical thinkers would want to know where I got the information behind these statements. Then they would determine whether the information was from credible sources like peer-reviewed scientific paper or from non-credible source like a biased news organization. If the sources were credible, students might decide to change their beliefs based on what they had learned. One could argue that in the absence of people taking these steps to identify credible sources of information and of people reflecting on their behaviors in light of new credible information, people will continue to make uninformed decisions about environmental problems such as climate change or urban sprawl. Critical thinking skills help children to become more productive and conscientious members of society and even to become agents of positive change. Although critical thinking skills can be taught in many disciplines, STEM is particularly well suited to nurture critical thinking. Why? Because STEM disciplines deal with complex problems that don't lend themselves to one-dimensional, easy solution and that require questioning conventional ways of thinking. Now, let's explore critical thinking skills, including interpretation, analysis, evaluation, inference, explanation, and self-regulation. Interpretation is the ability to understand meaning and categorize ideas and understand their significance. To practice interpretation skills with your students, you can discuss, for example, the significance of climate change in triggering hurricanes, typhoons, fires, or droughts. Analysis is identifying arguments and examining ideas. To strengthen analysis skills, your students can examine concepts and assumptions underlying the design of green buildings, for example, by exploring how solar power, smart appliances, and green roof work together to lower a building's climate footprint. Evaluation involves assessing claims and arguments. If you have a classroom debate about wind as a source of alternative energy, students can critically evaluate upsides and downsides of installing wind turbines from the standpoint of economy, biodiversity, and climate change. Inference encompasses questioning evidence, considering alternatives, and drawing conclusions. In STEM learning, students draw conclusions from scientists or their own research results, and they should be able to judge credibility of these results and decide the course of action given at times incomplete information, complex evidence, and statistical probability. Explanation includes stating results, justifying procedures, and presenting arguments. You can help students build coherent presentations of an STEM project by asking questions that force them to logically explain their results and recommendations. Self-regulation refers to examining your own assumptions and correcting your own understanding, learning, and decisions. Help your students to step back and consider how their biases, judgments, and experiences influence their research and their environmental action. As your students improve their critical thinking, they will be able to make decisions based on credible information, change their viewpoints based on new information, and often ask the question why until they understand the root cause of a problem or come up with a well-reasoned explanation and solution.